So our next speaker, Mr. Dennis Fox Bonilla, is a results-focused leader in technology development, strategy, and implementation with a proven track record of innovation and expertise in spatial computing with data visualization. Over 25 years, Fox has developed cutting-edge VR educational platforms, space mission planning software for NASA, decision support systems for U.S. agencies, and has served in roles supporting communities advising U.S. President Barack Obama about options for future human spaceflight. Mr. Bonilla is a company founder and technologist who thrives in rapid problem-solving environments. In addition to his CEO duties at Harbinger, Mr. Bonilla serves as an adjunct faculty in the School of Arts, Media, and Engineering at Arizona State University. Fox also provides insight and guidance regarding XR and spatial computing industry best practices as the co-chair of the Privacy and Safety Working Group at XRSI. He's a really cool guy, and he's got some fun stuff to show you. With that, Fox Bonilla.
We had to commit to the idea, right? So let me make sure I'm set up here. Just making sure I've got all the tools I need. So really, where I want to start is around these words that kind of look like word salad, right? The idea here is that there are a lot of concepts that are going to be converging. And so I'll be talking over the next hour or so around that convergence. I believe that a lot of us that are attending this conference come from different industries that we see are being affected by a variety of technologies that overlap in a lot of different ways. We may not be familiar with some of that overlap. So the conversation that I hope this will kick off is around where we might find places for unity and interoperability. But first, let's talk about hype. For those of you that are not familiar, this is the Gartner hype cycle. Kind of found some popularity around, oh, thanks. It found some popularity around 2016, 2017 when AR and VR kind of started to emerging in its current form. What the Gartner hype cycle does is it shows us different stages of adoption for a technology. In this case, we're looking at the hype cycle that is specific to artificial intelligence. This hype cycle was produced in 2023. I'll walk you through some parts of it. I won't go too in-depth. These slides, I think, are going to be available afterward, and you can literally Google Gartner hype cycle for AI to find this. So looking at this in 2023, and we know how fast AI is evolving. Some things will have changed, and some expectations will have changed. But I'll just walk you through where we were roughly like 6 to 9 months ago. What we've got across the bottom axis is some set of labels that happen over time. Typically, we're looking at kind of a time scale of about somewhere between 5 to 10 years from that end of the chart to this end of the chart. Kind of changes depending on the technology, but you'll see kind of where we are at this moment. Across this bottom axis, I'll just read to you what we're looking at. An innovation trigger occurs, right? This is some kind of new material. It's a type of new computational model. It may be a new type of processor. It may be a new type of vehicle. After that innovation trigger occurs, we're all hyped on it. We think it can solve all the world's problems, that it's better than sliced bread. And we end up in something called the peak of inflated expectations. It'll solve everything. Everything will be optimized, it'll all work, which is rapidly followed by the trough of disillusionment. Those of us that have been in VR for a while have kind of seen that cycle happen several times. There was a point in the 90s where there was an idea of a mass adoption for virtual reality technologies. Artificial intelligence also went through something like that in the late 80s. What this is explaining is the current generation of artificial intelligence. After we leave the trough of disillusionment, we end up, hopefully, in the slope of enlightenment. And these are technologies that have gotten us through the trough And we're starting to see the affordances that are possible with this type of tech. After we leave the slope of enlightenment, generally we end up in the plateau of productivity. And that now means this is a mass-adopted technology we use every day. Televisions, computers, cars, airplanes, things that went through the innovation trigger, the peak of inflated expectations, the trough of disillusionment, the slope of enlightenment to end up in the plateau of productivity. So 6 to 9 months ago, the peak of inflated expectations is generative AI, foundational models, responsible AI, nomorphic computing, artificial general intelligence. We're still talking about that. That was right before that kind of peak in that slope. We're starting to arrive at super hype around that artificial general intelligence. So generative AI was kind of supposed to go into this trough of disillusionment, but it hasn't yet. This is one of these few technologies that we're seeing might upend this type of chart. So this conversation is around the convergence. I told you a little bit about artificial intelligence and what we were looking at last year. What is an immersive experience? This is my expertise, my domain. So an immersive experience in the current context is a form that engrosses individuals by creating a convincing sense of physical presence within a simulated environment. I'm talking to you right now through a heads-up display that has a sensor suite in front of it. It is creating a synthetic version of the view that I might have without this headset. The latency is low enough that I can catch a thing in the air. I could probably hop off this stage if I wanted to, which I won't be. The technology has matured to a point where it is almost indistinguishable from reality. That is both frightening and incredibly intriguing. Where have we been? I don't know where all you have been, but I'll give you an idea of where I have been, and we will continue this conversation around convergence. So about 20-ish years ago, I was at the beginning of my career working at a NASA contractor, helping the space agency describe long-duration space missions. My background really was around games. Not really any kind of formal training, just an interest and a passion around game development and game engines. There was a unique moment right at the beginning of my career where there was a conference held by Mission Control down at Johnson Space Center. And what they wanted to find out was, what is the state of the art currently around multi-user environments, digital environments, simulated reality? Again, I didn't have any real formal training, but I had worked a lot in the modding community in video games. My formal background really was in graphic design at the time, come from kind of journalism and advertising. And I was asked at that time, I want a system that is Command and Conquer, The Sims, and The Matrix, all combined. At that time, we were having an all-hands meeting. The CEO said, does anybody here have any idea what I'm talking about? And I was around 24 or so at that time, and I raised my hand, and I was like, I think you're talking about a game engine? Okay, yeah, we're talking about a game engine. It's the macro view and the micro view. We're able to traverse many worlds. We're able to dynamically look from different perspectives at a form of reality, a synthetic reality. CEO asked at the time, so how long do you think it would take to put together a minimum viable product demonstration for Mission Control? The person that's holding this conference at that time was the head of Mission Control down in Johnson Space Center. And I was calculating it as a 24-year-old. Oh, okay, no problem. 3 months. Great. You have 3 weeks. That led to a larger conversation around the integration of multiple simulators that could not speak to one another, and developing a platform that allowed them to display simultaneously all that information to an engineer planning a space mission. This is the Distributed Observer Network. This was produced by a team of about 15 to 20 people over about a year and a half. The previous proposal was that it was going to cost $12 million and take 5 years to do. This was 1.2 million in 18 months, using off-the-shelf technology game engines, things that we now kind of understand, things that have been adopted by our industry. This is a recent project. I was working with a community college organization and a workforce development organization that split the bill on this one. And what it is it's a digital twin of a factory where they develop wire harnesses for Apache helicopters. In this particular synthetic digital twin, the purpose is to be able to take these types of jobs and the factory itself out to a high school, put a VR headset on a 14 to 16-year-old, and have them try for themselves a version of the job they might have in that factory. At that point, they have the choice of asking for more information or even getting a tour of the actual facility. In this case, like I said, this is not a place that you can go without some kind of clearance. So we have an opportunity here to modify that digital twin so that it is, let's say it's distributable. We're not putting anything inside of this that the company that runs that factory doesn't want the public to see. This next one's slightly different. This was an aerospace company that reached out. They had heard some of the work that I had done before, and they said, we've got this rapid development issue where we have a major milestone meeting with NASA, and we want to show them the interior of a spacecraft. The spacecraft itself, we have designed it over the last few years, but we're having some difficulty with portability. We want to be able to take this spacecraft and take it anywhere. We're talking about potentially a piece of hardware that would cost hundreds of millions of dollars to develop. So by creating a digital twin of that particular piece of hardware, you now have the ability to take a multi-million-dollar room and put it anywhere. In this case, I want to talk a little bit about a generative AI. So it was a highly accelerated deadline. I know that they had been working around making a portable version of it for about 7 months, was running into some difficulty with this CAD-accurate model. We had 7 weeks to solve it, to make it fully traversable, interactive, portable, that kind of thing. One of the things that our team did, so we work with folks that work on Marvel and Star Wars properties, so kind of best in class, people that are extremely fast, extremely efficient, and the best at what they do. Still not fast enough to get this done in 7 weeks. From their best perspective, the numbers that I was getting was somewhere in the order of like 3 months to complete this project. So 7 weeks, I needed to shrink 3 months into 7 weeks somehow. In this case, we came up with a workflow using a custom version of Stable Diffusion that we had installed locally. Trained it on some imagery that we were interested in, some work that we had previously done, and we were able to do transformations from image to image. Those that are unfamiliar with Stable Diffusion, it can be used as a prompt-based system. You can kind of start to type into it and then it produces a piece of art for you. However, there is a modifier that you can introduce called image to image, which means that when you submit an image, it will take the form of that image. So in our case, what we developed in our pipeline was a low resolution render, something that you can do, the best of the best can do in probably 2 to 4 hours, and then take some time to do the transformation to end up with an image that looks like this. I would say that's another 2 hours of work on top of those 2 to 4 hours. So now you're iterating in a half a day instead of 2 or 3 days at a time. So now you can start to see how you can shorten those weeks. If you pay people well enough, they will work through the weekends and maybe even holidays. I don't like doing that, but in this case, again, we only had 7 weeks to produce something that needed to blow the socks off of NASA. So what we did is we did a rapid iteration, some rapid iteration milestones. The company said, okay, so We've seen stuff like this, or we've seen a similar type of pipeline with 3D modelers. So those renders, those will be done in like 3 or 4 days, right? Okay, it's Monday. No, actually, I need your engineers tomorrow morning, because they're going to review all of these updated renders by tomorrow morning. So yeah, but you've got 18 renders. Is there like an army of people working on this? Yes and no. We've got some unique technologies. What we'll do is we'll optimize, and we'll make it work for you all as well as it works for us. So it was an excellent final product built on the Quest 2. So it was a highly performant 90 plus frames per second. Those of you that are VR geeks, 90 plus frames per second, high resolution textures, fully immersive environment. I've seen people spend up to like half an hour in it. Something kind of like a 3D brochure, kind of. Again, 7 weeks. Had we had 7 months, given that workflow and given those optimizations that we're aware of and the grand affordances that are available through these technologies, you could make a synthetic kind of version of this thing to maybe do engineering meetings in. One thing that we didn't do in it, which I would have loved to, would have been a multi-user environment. We just didn't have enough time, and it wasn't really what they were looking for. So that's where we've been. That's the past. Old school. Like, I'm over it. Where are we going? Where are we going? These are 2 images, both synthetic. Right? We're leaving the valley of the real. This is a method called photogrammetry. It creates novel synthetic views of an environment through the use of images. Now, those images can come from a 60 or 30 frame per second video capture. It can also come from a very high resolution DSLR. It all depends on your use case. Like how high quality do you want? How much do you want to chase reality? So this is not real. Like, this is a synthetic version of something. This is also a synthetic version of that something. In this case, this is a point cloud. Point cloud is a representation of the, essentially, depending on how you're producing it, it can be the vertices, it can be representational of materials. What you're doing here is a very light but very dense 3-dimensional representation of this environment. What I'm showing you, though, is that you can take computer vision now with this synthetic environment, this digital twin, and start to do some segmentation with computer vision. So I've got a point cloud that the computer doesn't care. It's not like us. It doesn't have to be actual like 3D solids. And it's figuring out volumes inside of that 3-dimensional environment, and it's segmenting it, and it is categorizing it. In this case, these are all chairs, right? So now that computer vision technology has looked at a 3-dimensional novel view and identified where all the chairs are, maybe where all the screws are, maybe where all the portholes are, maybe where all the other robots are. This is what's possible with artificial intelligence trained on a computer vision algorithm trained on chairs. Another algorithm trained on environment synthesis. These are layers of AI and algorithms now, okay? Can I get a raise of hands? Who likes Cheetos? Yeah, me too. So Cheetos. I'm out to dinner with my wife and a couple of really great friends, and I'm taking in the smells of the barbecue, and he's been cooking for like 12 hours. This dude gets up at like 2 in the morning and like goes and he changes the meat. Like the commitment to this meal is out of control. He smokes the Cheetos. Okay? So I'm flabbergasted. This is a dream. I need to remember this moment. I'd been reading a bit about neural radiance fields, what neural radiance fields do, they take that previous technology of things like novel synthetic view or novel view synthesis, but it goes about it in a slightly different way. It starts to measure how photons are traveling through the images, and it's identifying that and calculating it to the nth degree, depending on your processing power and how much resolution you want out of that actual simulated environment. So this neural radiance field, it is capturing things like transparency, reflections that you can't really capture with photogrammetry, which is the previous technology. Now, what's really great about this set of novel views is that they feel like the real. And like I said, it's a dream. And I get to keep it forever. Okay? So this is where we're arriving. Synthetic views that now are nearly indistinguishable from the real. I want to show you one other version of this. This I did on the home computer. You can see some of this floating stuff happening. Don't worry, that's been refined. We can get it so that you won't know whether you're in the matrix or not. That being said, here's an off-the-shelf version of the same kind of thing. So Nerfs, Smurfs, Splats. This is a web-based interactive display of a castle produced with the help of machine learning. Research in the area of 3D Gaussian splats have recently produced the ability to display complex photorealistic 3D scenes at a high frame rate on the web. On the web, right? Smartphones can actually show this off. That's now. That's like in the last couple months. So 3D novel views, nearly indistinguishable from reality on a portable device. If only we had something that we could view those things in. All right, so that's interesting, but it's still based on reality, okay? I know we had some presenters talk about creating art and facilitating the development of art for entertainment purposes. That was a really great presentation yesterday. One of the systems that was discussed was Comfy UI. So Comfy UI, we talked about transformations earlier. Comfy UI is a system that sits on top of Stable Diffusion that gives you much more, many more options for the type of transformations you want to do to an image. It also gives you opportunities for different types of output. So things start to get kind of weird. We start leaving that even reality-based novel view synthesis. What if you took the collection of all the images for that castle or for those Cheetos and you ran them through a transformer to create an animated scene, a scene in a different time, a scene with different types of people, maybe a scene that is culturally relevant to someone else, right? And we can now do that in near real time. Like I said, both frightening and incredible. Lots of tools are starting to pop up now that we know that we can run a large language model, we can run something like Stable Diffusion on a M-class MacBook Pro. Even a Mac Mini will run it without breaking a sweat most of the times, depending on what you're trying to do. We're starting to see all these different services pop up that are these types of transformations. This next one I'm going to show you is a Chrome extension. I'm not even going to touch the intellectual property issues here. We can talk about that during the Q&A. But this is a Chrome extension, what I'm showing you next, called Glyph, that can be used to remix any image on the web with something called an IP adapter. Yeah, it gets pretty crazy pretty quick. So let's talk about possible use cases now that you've seen kind of where we've been, where we're going. Enhancing realism. AI algorithms can be used to improve the realism of synthetic environments by generating realistic textures, lighting effects, and physics simulations. Natural language processing. AI-powered natural language processing can be used to enable voice commands and interactions within immersive applications. Right? No longer does it need to be static. It can actually maybe converse or provide some context to you about that environment. Intelligent avatars. AI can be used to create intelligent digital avatars that can interact with users in more human-like ways. Adaptive experiences. This is also an interesting one to me. AI algorithms can analyze user behavior and preferences to dynamically adapt the immersive experience based on individual needs. Maybe it's closed captioning. Maybe it's oversizing text for folks that are visually impaired. Maybe it's changing the language entirely. Maybe it's a color correction of some kind that's necessary. In learning environments, that is a whole other set of angles that we can take. Do we need to change the way the test is performed in real time? Do we need to change the environment that you're learning in to make it more accessible to you as an individual? Object recognition, which we talked about there at the beginning. So AI can enable immersive applications to recognize and interact with real-world objects, enhancing the level of immersion and interactivity. I don't know if Space Camp would have let me do this, but right, putting an IoT device somewhere in this room so I could just like do that and all the lights go out. Right? That's where this convergence is occurring. So let's talk a little bit about challenges and limitations. So things to watch out for. Processing power. AI algorithms require significant computational power, which can be a challenge for immersive applications that need to run in real time. This wouldn't be possible. What I'm doing right now, here's kind of the cheat code, up, down, down, left, right, is that the notes are here for me. They're up here. Sorry to take the magic away. So data requirements. AI algorithms often require large amounts of training data to achieve optimal performance, which can be a limitation to applications where data collection may be limited. Surface of the moon. I was supporting a field trip down in Arizona, and the kids really, they weren't familiar with Mars. These were young kids from underserved communities. And so one of the things that I did was I post-processed some NavCam data off of MSL, off the Mars rover, and I made it so it was a three-dimensional view of what the Mars rover was seeing. And then I split that across two images, a left and right eye image. I then put a phone, swapped it, popped it into a little cardboard device. Super, super lightweight. The kid sees it, right? It's one of these dealies. And they're now looking at stereoscopic versions, stereoscopic point of view from the surface of Mars. Mind-boggling stuff that isn't possible, one, without the computational power that we've got on the surface of Mars, but two, it isn't possible without that novel synthetic view. User experience. So while AI can enhance the realism and interactivity of applications, It is important to ensure that the AI components do not negatively impact the overall user experience. The one that I get often, and it's unfortunate, is, no, I'm good. VR makes me throw up. Yeah, not my VR. If you have people that are aware as well as respectful to the end user, these technologies can be used for infinite good, right? That's the plus side, that's the upside. I'm not gonna put you in a thing that's gonna make you sick. Like, why would I do that? Like, my whole life has been devoted or in service of scientific discovery. Like, what little effort I can make to push things forward, that's a compliment, you know, to what I can do and what I want to do. So I'm always super respectful. If we can distribute information to one another, if we can have these interesting conversations, if we can see things from novel perspectives, that's the role, or that's a type of role I like to fit into. Don't make the user sick. I try to avoid things that are gonna bring pain to someone. In some cases, I know we were talking about the Shoah experience, the last goodbye. That was a Holocaust survivor's experience that I was the lead developer on. Sometimes you kind of got to go through it too, right? We're putting you in into Majdanek, which was a concentration camp in Poland. I'm sorry, but some folks, you got to go through it to feel it and actually learn from it. And then ethical considerations. I should have put this at the top of the list. My fault there. As AI becomes more integrated into application development, ethical considerations such as data privacy, bias, and transparency need to be addressed. This is why I volunteer with XRSI. Previously, it was called the XR Safety Initiative, kind of cross-functional, global initiative, researchers giving their time from, I don't know, I think it was like 70 different countries, like hundreds of different people, trying to create frameworks around AR and VR technologies to say to these companies, listen, we know you can train your systems on this. Please refrain from doing so by committing to adopting to these frameworks. Here's an interesting one. With not a lot of data, individual gait, that is the way a person walks, allows them to be recognizable within a group of people. So with, like I said, not a lot of training data, in a group of 1,000 people, I could pick you out just by the way that you walk if I have the right gait analysis information. The same kind of gait analysis, the same kind of, eye recognition, things that are going on with game hardware. So, what is spatial computing? Spatial computing refers to the use of technology and algorithms to understand and interact with the physical world in real time. It involves creating a digital representation of the physical environment and overlaying virtual information onto it, enabling users to seamlessly interact with both the real and virtual worlds. This is something I'm doing right now, right? So, like, this is controlling the laptop that is showing you guys this. The notes are up here while I'm in headset. Fully integrated, fully converged. There are some arguments around semantics here. We can call it some form of augmented reality. We can call it some form of mixed reality. If you talk to anybody that's been in this industry, you'll end up in a 2-hour-long debate as to what differentiates this from VR. I'm not interested in getting into that debate with you. I'm just telling you what's here now. On the left is a Quest 3. On the right is the Vision Pro. Both devices use inside-out wireless tracking to present real-time virtual reality and augmented reality content, as well as this spatial computing ability, which is general computational power that's available to us now inside of the headset. Apple's marketing their device, this one, using the term spatial computing. We've now seen after its launch that Meta is kind of rebounding from that rebranding and trying to see how they might fit their Quest line of products using the same type of terminology. For all intents and purposes, you're going to get a similar type of experience, not necessarily the same, but they're also widely different price points. So I wouldn't be expecting to get the same power from a Quest 3 as I can from a Vision Pro, in the same way that I don't expect the Vision Pro to be as affordable as the Quest 3 given its limited sensor suite compared to that of the Vision Pro. So there was a Wall Street Journal review of the headset, of the Vision Pro headset, and everybody's trying to kind of get their heads around how does this thing get used if I don't have game controllers? Like, what use could you possibly have with just your hands? So here's a great example from that Wall Street Journal review by Joanna Stern. She had an aha moment. The instructions say not to cook and not to go skiing, and us being, I guess, the monkeys that we are, that's what we're going to do. So let's cook a meal. Aha. Right? I failed myself on this one. I was hoping to have like a little timer here for myself, but sorry, didn't move fast enough. This isn't new. We've seen this before, but this was science fiction. So, where did we see it before? I'm a huge comic book geek. Where did we see it before?
Initiating virtual crime scene reconstruction.
Okay. What do we got here?
That was like a decade ago. Like, that was a decade ago, and it was like, oh, that's the future. Like, I hope I'm alive when that happens. Examples of AI-enabled immersive applications outside of recreating a crime scene. Things we can build. Virtual training and simulations. AI-powered immersive applications can provide realistic training simulations for various industries such as healthcare, aviation, military. Military, of course, has been doing this for a long, long, long time. Gaming and entertainment. AI algorithms can enhance the gameplay experience in immersive games by helping creating environments and adapting the difficulty level based on player performance and behavior. Sounds a lot like education. Virtual collaboration. AI can facilitate collaboration by enabling natural language processing, there it is again, and intelligent avatars allowing users to interact and communicate in virtual environments. We're not there yet. We should meet up in maybe 18 months and have a conversation about what Siri looks like then. The concepts that are leaking out is that Apple was put on notice by OpenAI as soon as their APIs became available about 2 years ago, and have been furiously hiring folks to create large language models and translators and adapters that can function on your phone. If you've been watching some of the open source code that they've been releasing, one of the major, let's say, innovations that they've been responsible for in the last 3 months or so is being able to run an LLM performantly on an iPhone 14 and higher. If you think about that, that means that that whole infrastructure that ChatGPT has, or some variation of it, could run on your phone. Right? That's pretty powerful stuff. If we thought if we thought it felt like having infinite power to reach it through a web window, imagine what that looks like with NLP. Architectural visualization. Architects have also been using this type of technology for a while. AI is going to get really interesting for them. They can use AI algorithms to generate realistic synthetic environments based on architectural designs, allowing architects, engineers, and clients to visualize and explore spaces before construction. I worked on a project about 14 years ago. It was a Department of Defense building, about $2 million. No, that was 10 million square feet, several floors of a building that had to be synthetically developed 6 months prior to the facility actually being constructed so that they could do security training. There were so many people that were going to go into that building, they didn't want to open that building without those folks having had months of training prior. That wasn't even using AI at the time. So if you think about it now, imagine taking a DWG file, some kind of architectural diagram, maybe a CAD file, maybe a BIM model, feeding it to an AI and saying, hey, give me a CAD accurate representation, three-dimensional CAD accurate representation of this building, go. Kind of what we just saw Jarvis do. But I get this, I get this sense that like the idea is that we all think spatial computing or even augmented reality or virtual reality only exists in headset. I want to show you an example that is really interesting to me. There's a company out of Brooklyn that is working on holographic displays, affordable holographic displays. We're talking like sub 1,000 for something that we can carry around. What if we talk about that convergence thing and bring together a large language model with a 3D representation with a holographic display?
Holograms from all the big companies have been stuck in headsets. That's cool some of the time, but what about the rest of the time? This is Looking Glass Go, a new type of holographic display that works without headsets, combining the power of generative AI with holograms. Here's how it works. This is what your memories look like today. That's me. But this is what your memories will look like from now on, in the future. Our software turns regular photos into spatial photos. We do this by using an AI algorithm to imagine dozens of perspectives of that same memory. The Looking Glass Go then projects out millions of rays of light to bring that photo to life in the real world as a hologram. If you've got a newer phone with multiple cameras, you can use advanced techniques to push the limits and do even more. The Looking Glass Go can also run holographic apps, including one that's very special, because it can make ChatGPT holographic.
こんにちは、はじめまして。私はホログラムです。
By combining the realism of holograms with ChatGPT, now you can create seemingly impossible things.
Portable LLM running on my iPhone connected to a Looking Glass Go. That looks kind of interesting. That's not even like tomorrow, that's like 2 hours from now, right? Future trends and possibilities. So potential applications, completely AI-generated worlds. We're seeing that in video games already. AI algorithms could be used to generate entire synthetic worlds, opening up new possibilities for immersive experiences. Games that never end, kind of scary also. Emotional intelligence software. AI could be used to develop digital characters with simulated, not real, they're not humans, remember? Simulated emotional intelligence, enabling more realistic and engaging interactions. I'd love to see these avatars maybe help make us better people, all of us. Personalized experiences. AI algorithms can analyze user preferences and behavior and personal content to create experiences tailored to individual needs and interests. We just saw that with the holographic avatar, the holographic friend. AI-powered haptic feedback. AI algorithms could enhance haptic feedback in immersive applications, allowing users to feel more realistic sensations and textures. You can imagine the industries that are heavily interested in that space. We're kind of approaching the end of the slides. I guess I ran through them quite quickly. But it's not really the end because we'll have a conversation and all this stuff is just starting. AI has the potential to significantly enhance the development of interactive, immersive technologies by leveraging AI algorithms and machine learning. VR experiences and spatial computing applications that can become more realistic, informative, and personalized. However, it is important to consider and address the challenges and ethical considerations associated with AI integration into devices and experiences that can motivate and manipulate humans. If Apple plays it wrong, and the inferences that are made on your iPhone now running your hologram that is telling you where you need to be and when, you're driving into a lake. We've seen that before. You're calling the wrong person. You are maybe making assumptions about relationships or types of communication that are misinformed. There are all kinds of things that we can stumble on, and I think part of this conference is to talk about both the emerging use cases as well as the potential for harm, and some of the frameworks we should be thinking about to mitigate that potential for harm. So, again, this is not the end. And what would I do? Like, where would I take you all? If I could take you somewhere, right? If we were having this in the Dome in Vegas, right? Where might I want to go to kind of wash us up a little bit, kind of refresh us a little bit? Remember, novel view synthesis only requires a few seconds of video, a few dozen images. What's a place that we could go together that we can't go right in this moment? Maybe underwater. With no fear of drowning, right? Forever and ever and ever. We just all became mermaids. I want to thank Space Camp, Chris, Robin, everybody that's been involved with creating this conference. This has been incredibly elucidating, as I've said to the folks here. The presentations have been absolutely stellar. I will for sure be telling everybody to come back next year, and folks that weren't here, I'll be inviting them to come. Thank you for the opportunity to talk about the future. I'm happy to answer any questions you might have.
My first comment is thank you for including Totoro in there. I'm a big Totoro fan myself, so I appreciate that. One question, you and I talked a bit about some of the ethical stuff yesterday, and when you were, there was this one slide where you were talking about that sort of immersive space, and you mentioned people saying, well, I'm not going to do that, I'm going to get sick in there. And you said, well, I would never want anybody to get sick. So my question for you is, number one, that was my first reaction. One of my reasons for not wanting to immerse myself in that is vertigo and other things that would drive me nuts. You said that your VR wouldn't do that. My question is, how do you address those kinds of sort of non-technical impacts of your technology, things like health issues and whatnot? How are those addressed in your development process?
So what I've seen, unfortunately, with the adoption of immersive technologies is a lot of focus around games and entertainment and not enough focus kind of around the humanistic components and the physiological components. Here's an interesting one for you all. Women that are on their period are more likely to get motion sick in VR. How many entertainment companies do you know that would tell you that? It takes research. The Navy's done a bunch of stuff around flight simulators that informs the work that I do. Of course, a lot of the work that I do comes from NASA tech. So I have to be thinking constantly about what are the potential use cases, what's the user experience, how am I avoiding these potential factors that may cause either a crash in the system or death. Because the systems that I work in typically require a human in the loop in a simulation. The last thing I want to do is create an issue for them. Research. Honesty, transparency. I've already encountered companies that are willing to completely sell their users out for a quick buck. Yeah, we can do it quick. I don't really care if it makes them sick. I'm not interested if we make the simulation and the person dies. Like, I've literally heard that already. So we need to be, as both consumers, constantly asking these companies to stand by what they're saying and prove it. And as an industry, we need to get our act together and make sure that we're building systems that are not taking advantage of people or hurting them. I hope that answered your question.
Kind of along that same line, and it's a little bit of a two-part question. In Web3, we've seen things we hoped we wouldn't see, so-called sexual experiences or assaults in a Web3 world. Would we potentially see that in an AI-generated world? And then the second part of the question is, do you think we're going to see a shift of some of the things that we were heading toward in Web3 and may still be headed toward, taste sensation, the ability to feel, interpret and so forth. Are we just seeing that kind of shift over, or will it be more of a parallel path, do you think?
Okay, so there are two parts of that. The first one, so if we're talking about training models and we're talking about the efficacy of a large language model or maybe generative AI art platform, are we training them on intellectual property law? Are we describing to them frameworks that prevent human harm? Like you'd kind of think that if you were creating an AI platform that are going to influence people and interact with people, that's where we would start. I'd like to think that the industry would do that, but we haven't seen that. So it takes folks like us, folks that are interested in having that conversation, to go back to our organizations and say, hey, maybe what we need to do is introduce some additional frameworks to make sure that we are preventing harm here, or stealing of other people's property, intellectual property, or I don't know, like circumventing some of the security mechanisms that we don't jump over as humans, but for whatever reason have allowed AI to. The second one, if I can remember it, so there is quite a bit of research happening across a lot of different industries that may or may not converge. And the reason I wanted to call this presentation Convergence is because I could identify some that are, for sure. They're already happening. They're systems that I'm working with. They're systems that my peers have been working with that they've described to me that are extraordinary. You brought up smell and touch. This is an interesting one. I was at CES, the Consumer Electronics Show, a couple years ago, and there was a haptic feedback suit. Looked like a sausage getting into this thing, and it's like a gigantic suit. And I'm in the suit. There's no VR yet, and I'm watching on the display what I'm supposed to feel. And I get electrocuted. That's funny to you. I'm on the trade show floor at CES looking like a sausage getting electrocuted. It was shocking. Traumatic, I should say. It turned out, after a brief conversation with the engineer helping me, that the development team decided to default out of 1 out of 10, 10 being the most shock, to default at 10 during user configuration. That doesn't make any sense, right? And I don't know why they would do that. I asked, and they're like, oh yeah, if people have said that throughout the day, and I was like, okay, so maybe you want to like turn it down before you shock somebody, but it didn't happen. What was wild though, was after that shock, is that I put on a VR headset, and the person said, okay, we're gonna go on a walk in the rain. And so I'm going on this walk in the rain, and the raindrops are hitting my shoulders, and the raindrops are like running down my chest and like down my arm. And I'm in headset feeling the rain happening. Like I said, there were two examples there. One is I'm just in the haptic feedback suit looking at a 2D display of something. There's no VR, right? This is where that whole nomenclature thing kind of starts to fall apart. Is that virtual reality? Is that a synthetic reality? What is that? Is that spatial computing? I don't care. Like, I just know that it's happening. It's happening to me. So I guess the simple, not simple answer there is there are immediately obvious opportunities for convergence between these technologies, and then there are not so immediately identifiable ones. And we need to be sure, as we discussed yesterday after the ethics presentation, that we should be thinking about the ethical implications before we run into them.
So thank you very much for this. It's been very fascinating. And I wanted to go back to your barbecue experience.
Cheetos.
Because I'd never run across that technology before, and you were talking about how you were doing it on a laptop. And I was wondering if you could just kind of talk about it a little bit more, because for those of us that are working on digital twinning, that seems like a technology that gets us way ahead of where we are.
Okay, yeah. So you saw the kind of the cloud kind of foamy thing happening around the edges of it. That was because I had limited compute on that particular machine. It was running off of GTX 1080. It was a NVIDIA machine. It's essentially using the tensor compute capability of a 1080 to do a what's called a neural radiance field. If I was looking for that tech, instant NGP would be something I'd be looking for on GitHub, instant NGP. If you've got a 2090, 3090, if your lab can afford a 4090, you can start to get a bit more fidelity further out. I could have cropped it out, but I wanted to have some discussion around the kind of foamy stuff that was happening. As we get greater and greater compute capability, that will only get clearer and clearer and clearer. That was a 15-second video capture at 60 frames per second. So what is that, 58? 900 frames? 900 frames. What you want to do is avoid any blurring between frames. It's very similar to photogrammetry. Very clear, precise images from different perspectives, maybe different heights. And then when it does the view synthesis, you'll get a much more complete digital twin of that particular environment. Welcome.
So what are your concerns as these tools continue to advance, that it's going to invalidate skills that might not develop naturally otherwise?
Skills. Do any skills come to mind?
Yeah, so, well, for one thing, you talked about an experience where people could view the surface of Mars in 3 dimensions. What happens when that gets good enough that people are just like, we've seen it, we don't need to go there now?
I think the onus is on us as a society, not on technologists. The inquisitiveness that has taken us to the edge of the solar system hasn't been under the purview of engineers. It's probably, I would say, been more influenced by second-grade teachers. So prioritize it, right? Make sure that we're still asking questions. Make sure that we're still having difficult conversations. Make sure that we're not making assumptions. Make sure that we have more information. Yes, it's synthetic, but it's synthetic now from 3 weeks ago. That's not what it looks like today. That NavCam capture, the closest I was able to get, which was pretty cool, was about, I think it was a 36-hour delta. Like, it was like 36 hours before was the closest I could get from now. So I couldn't quite tell the kids, this is now. I could tell them, that's like a day and a half ago. And that was good enough for them, but we should push that that's not good enough for us, right? How do you prevent it from being just robots traveling the universe? I want a trip, it's like I want a trip to the ends of reality. Well, again, thank you, and thanks for Space Camp for this opportunity. It's been a pleasure having this conversation with you all and getting to present in such a really cool place. So thanks for coming to the symposium.